So section 8.5, angles of elevation and angles of depression. Essentially, they deal with word problems involving trigonometry. So we'll get this in our notes. Section 8.5, angles of elevation and depression. So, an angle of elevation. An angle of elevation is always the angle made between the observer's line of sight and an object. So let's say you're looking at a birdie up in the air. Your eyeball to that birdie creates an angle with the horizon line. And so that angle is the angle of elevation. And we can use that angle of elevation along with the bird's altitude to solve right triangle problems using trigonometry. Angle of depression is a similar idea. In this case, let's say you're standing on the edge of a cliff, looking down at an object. The angle of depression is again made with your line of sight and the horizon line. So the angle of depression is that angle. The distance from the horizon line to the object that you're looking down to, that creates a right triangle, and so we can solve using trigonometry. In addition, the triangle sort of below that given triangle, this triangle down below here, is also a right triangle, and by alternate interior angles, the angle of depression is congruent to that green angle shown there. And so we could solve for, let's say we could solve for x using trigonometry. The key idea with both angles of elevation and depression is that they are formed by the observer's line of sight and the horizon line. So now let's take a look at a couple of examples. Example 1. Let's say a tree casts a shadow 25 feet long. At the tip of the shadow, an ant looks up to the top of the tree and somehow determines that the angle of elevation is 64 degrees. Find the height of the tree. Well, let's draw pictures. We know we have a tree, and the tree is casting a shadow, and we know that the length of the shadow is 25 feet long. And at the very tip of the shadow is an ant, and somehow that ant figures out that the angle of elevation is 64 degrees. And we want to find the height of the tree. So we'll just use trigonometry. If you sort of recreate that triangle, we have 64 degrees as the reference angle, 25 is the opposite, 25 is the adjacent, and x is the unknown opposite. Since we want to find the opposite, we know the adjacent, we'll use the tangent function. So the tangent of the angle is x over 25. Therefore, x is about 51.258 feet. So the tree is that just about 51.258 feet tall. Let's try another example. So an airplane takes off, and it rises at a steady angle of 19 degrees until it hits an altitude of 28,000 feet. How much ground distance is covered? Well, again, we'll want to draw pictures. We have some airplane taking off, and we know that the angle that it rises is a constant angle of 19 degrees. And so therefore the angle of elevation is 19 degrees, and it continues rising until it hits an altitude of 28,000 feet. Remember, altitude is always distance from a certain height straight down to the ground. And we want to find how much ground distance is covered. Well, ground distance would be that horizontal line. So using 19 as an angle of reference, 28 then as an opposite, x is an adjacent, we'll use the tangent function. So the tangent of the angle is opposite over adjacent. Therefore, x is equal to 28,000 over tangent of 19, which gives us x is approximately 81,317.9 feet. However, the question asked us for ground distance covered in miles. And remember, 1 mile is 5,280 feet, so we'll take our x answer and divide by 5,280, so we get that the ground distance is about 15.4 miles. Let's take a look at one more example. Let's say you are standing on the edge of a cliff, and it's a 40-meter tall cliff. You're looking down at a cactus. So you determine that the angle of depression between your eyeballs and the cactus is 34 degrees. How far is the cactus from the base of the cliff? So if we create a right triangle, we know that the cliff is 40 meters tall. And so that means the altitude from the line of sight, or pardon me, from the horizon line to the cactus is 40 meters long. Since the two highlighted lengths there are congruent, we can find one using trigonometry. The opposite is 40. We want to find the adjacent, and so the tangent of 34 degrees is 40 divided by x, which means x is 40 divided by the tangent of 34 degrees. And so we get that x is 59.302 meters. So therefore, the cactus is that many meters away from the base of the cliff.